Betelgeuse, a colossal red supergiant located in the Orion constellation, has captivated the human race for centuries with its intense crimson radiance and enormous size. Astronomers have estimated that if Betelgeuse were to be situated at the heart of our solar system, it would consume all the planets. This star's vastness extends to Jupiter, signifying that it is nearing the final phase in a star's lifespan, preparing for a disastrous end result, an explosion now known as a supernova. Betelgeuse, on the other hand, has demonstrated extremely unusual behavior. Its luminosity surged by more than 50%, catapulting it from the 10th to the 7th brightest star in the night sky. This unexpected flare of brightness led scientists to scramble for answers. Was this an early warning of its explosive demise, or merely a temporary blip in its life cycle? The ramifications of this are immense. If Betelgeuse were to go supernova, it could brighten the night sky to the point where it would become day into the night, producing extraordinary opportunities for science. A star's brightness is influenced by its size, temperature, and distance from Earth. Betelgeuse, with a radius more than 700 times that of the Sun, is relatively cooler, with surface temperatures between 3,000 and 3,500 Kelvin. This gives it its signature red hue. Its size, combined with its low temperature, makes it a prime potential host for a supernova, making its recent behavior all the more intriguing. Betelgeuse stunned astronomers once more in late 2019 by dimming to 40% of its usual brightness. This dramatic change, visible even without telescopes, led to widespread observations and debates. Some speculated that dust might have obscured the star, while others considered internal processes at play. The possibility of an imminent supernova became a key topic among experts. Using the Very Large Telescope, VLT, in Chile, astronomers succeeded in capturing specific images of Betelgeuse during its dimming stage. These pictures showed that the star had taken on a noticeably lopsided appearance. Further analysis suggested that this dimming was probably brought on by a massive surface mass ejection, SMME, where Betelgeuse expelled an extraordinary amount of material into space. This unprecedented event altered the star's appearance and disrupted its pulsation cycle, similar to a volcanic eruption, only on a cosmic scale. Betelgeuse ejected over 400 billion tons of material, far more than typical solar events. This upheaval not only changed the star's look, but also shortened its expansion period from 400 days to just 200. Such radical changes indicate that Betelgeuse is becoming more unstable, leading to more questions. How much longer can it maintain its current form? Due to its volatile behavior, astronomers have ramped up their monitoring efforts, eagerly searching for signs of its impending collapse. When a massive star like Betelgeuse runs out of fuel, its core collapses under the weight of its own gravity, triggering a supernova. This colossal explosion releases an immense amount of energy, blasting the outer layers of the star into space and producing a brilliant light visible even in the daylight. Should Betelgeuse explode, the initial burst of neutrinos would be the first signal. Tiny, nearly massless subatomic particles that travel faster than light and can escape from the star. These neutrinos would reach Earth hours before the light from the explosion itself. Once the light does arrive, Betelgeuse might shine more brightly than the full moon, casting eerie shadows and illuminating the night sky for weeks. A supernova of this magnitude would present an unprecedented opportunity for scientists to study stellar death in real time. By analyzing the emitted light, radiation, and heat, researchers could gather invaluable information about stellar evolution, nuclear physics, and the formation of elements essential for life. To understand Betelgeuse's unusual behavior, researchers are using sophisticated star model simulations. These virtual models incorporate data from telescopes like the James Webb Space Telescope, JWST, and the VLT, making it possible for researchers to investigate the processes that drive Betelgeuse's instability. These simulations have demonstrated that a sizable gas bubble likely formed deep within the star, triggering the SMME, and altering its pulsation rhythm. Observations from the JWST have provided a more in-depth look at the material that Betelgeuse ejected, revealing intricate gas and dust structures surrounding the star. These findings suggest that Betelgeuse may be nearing the final stages of its life cycle, offering an unprecedented window into the life of massive stars. While researchers anticipate that Betelgeuse could go supernova within the next 10,000 to 100,000 years, its erratic behavior suggests the timeline may be much shorter. The astronomical community is racing to capture every detail of this cosmic spectacle before it reaches its dramatic climax, ensuring humanity doesn't miss this rare event. In late 2023, the JWST, with its unparalleled observational capabilities, focused on Betelgeuse and discovered shocking new information. Scientists found the star, already in a state of instability due to its massive SMME, had undergone a rapid internal collapse. This collapse was indicated by significant changes in its core dynamics, which altered the flow of nuclear fusion reactions. Astronomers observed dramatic fluctuations in Betelgeuse's expansion cycles before the collapse, with the star's surface expanding and contracting steadily over 400 days. Afterward, this rhythm was abruptly shortened to just 200 days, indicating a significant disruption in the star's internal structure. This unevenness served as a cosmic heartbeat, signaling that Betelgeuse might be approaching the end of its life as a red supergiant. Simulations conducted by astrophysicists reveal that the star's core is becoming increasingly unstable as it fuses heavier elements. When stars reach this phase, they begin producing iron, a process that marks the final phase before collapse. Unlike other elements, iron doesn't release energy when fused, resulting in a mass accumulation that eventually leads to the core's collapse. Betelgeuse's recent behavior has sparked heated debates among astronomers regarding the supernova's timetable. While some contend that the explosion could occur within the next few centuries, others believe it could still be tens of thousands of years away. What is evident, however, is that Betelgeuse's time as a red supergiant is coming to an end. One key indicator that a supernova is imminent is a surge in neutrino activity, tiny subatomic particles that escape from stars during their defining moments. Scientists are monitoring Betelgeuse closely, keeping a watchful eye for any sudden spikes in neutrino activity. Instruments around the world are on high alert to detect this fleeting signal, which could provide humanity with its first real-time warning of an impending supernova. If Betelgeuse does indeed go supernova within our lifetime, it would become one of the most significant astronomical events ever witnessed by humanity. The explosion would unfold in several distinct stages, each offering unique insights into the life cycle of stars. The first detectable sign would be the arrival of neutrinos, signaling that the star's core has collapsed. These subatomic particles produced during the final moments of a star's life would travel through space and reach Earth within hours of the core collapse. Neutrino detectors, such as Japan's Super Kamiokande and the United States' Ice Cube Neutrino Observatory, are poised to register this burst of particles, acting as an early warning system before the visible explosion. Shortly after the neutrino burst, Betelgeuse would explode in a brilliant flash of light. The star's outer layers would be violently expelled into space, releasing immense amounts of energy and illuminating the night sky with a brightness rivaling that of the full moon, or even Venus at its brightest. This dazzling spectacle would last for several weeks, casting shadows at night and becoming visible to the naked eye even during the day. Following the initial explosion, astronomers would focus their attention on the expanding supernova remnant, the cloud of gas and dust left behind by the blast. Over time, this remnant would expand outward, dispersing elements such as carbon, oxygen, and iron into space. These elements, forged during the star's final moments, are essential building blocks of planets and life, highlighting the profound connection between stellar death and the creation of new worlds. The scientific community would seize the opportunity to study the supernova's aftermath using telescopes like the JWST, Hubble Space Telescope, and ground-based observatories worldwide. These observations would provide invaluable data on the behavior of supernovae, the processes that govern stellar evolution, and the formation of heavy elements. Additionally, space-based instruments would capture the gamma rays and X-rays produced during the explosion, offering insights into the high-energy physics of supernovae. As the supernova remnant continues to expand, it may eventually form a neutron star, a dense, rapidly spinning core composed primarily of neutrons. Alternatively, if Betelgeuse's core is massive enough, it could collapse further, forming a black hole, a gravitational singularity from which nothing can escape. Detecting the formation of either object would be a monumental discovery, shedding light on the final stages of stellar evolution. In the years following the supernova, astronomers would monitor the evolving remnant, studying its interaction with the surrounding interstellar medium. This ongoing research would provide insights into how supernovae shape the structure and composition of galaxies, influencing everything from star formation to the distribution of heavy elements. For humanity, witnessing the supernova of Betelgeuse would be a humbling reminder of the vast, dynamic nature of the universe. It would captivate people worldwide, sparking renewed interest in astronomy and inspiring future generations of scientists. Schools, museums, and observatories would host events to share this rare spectacle with the public, fostering a deeper appreciation for the cosmos. While the exact timing of Betelgeuse's supernova remains uncertain, its recent fluctuations and unusual behavior suggest that this momentous event could occur sooner than expected. Until that day arrives, astronomers will continue their vigilant observations, prepared to capture every moment of this cosmic phenomenon and unlock the secrets of stellar death and rebirth. Betelgeuse's supernova will be an awe-inspiring celestial event. Scientists say it will be visible even during the day. They assure us that it poses no danger to Earth. However, its brightness could rival that of the full moon, illuminating the night sky and casting shadows for weeks. This event will not only attract stargazers, but also provide an unparalleled opportunity for researchers to study stellar death in real time. The story of Betelgeuse reminds us that there are still mysteries throughout the universe waiting to be discovered. This enormous star, which has mesmerized humanity for centuries, continues to challenge our understanding of stellar evolution and cosmic dynamics. As Betelgeuse surprises us with its dimming, mass ejections, and unpredictable behavior, it serves as a reminder of how much we still have to learn. Its potential to go supernova provides scientists with a wonderful opportunity to study the life cycle of massive stars firsthand. Understanding these processes goes beyond determining the fate of a single star. It's about uncovering the mechanisms that shape galaxies, seed the universe with vital elements, and even make life possible. This knowledge could boost our understanding of the universe's history and our place within it. The tools used to study Betelgeuse, from ground-based observatories to cutting-edge instruments like the James Webb Space Telescope, have opened new windows into the cosmos, windows that previous generations could only dream of. These technologies enable us to conduct simulations, study stellar dynamics, and peer billions of years into the past, all to better understand the very fabric of reality. For researchers like Neil deGrasse Tyson, discoveries like these spark excitement and urgency. They push the boundaries of human knowledge and challenge us to keep exploring the cosmos. The next time you look up at Orion's belt, remember that one of those points of light tells the story of a star on the brink of its destiny. What do you think will happen to Betelgeuse? Are we witnessing the final moments of a star about to explode, or is this just another stage in its enigmatic life cycle? Share your thoughts and join the discussion about one of the universe's most intriguing stars. Don't forget to subscribe, like, and turn on notifications for more cosmic stories that will leave you in awe. Until next time, keep your eyes on the skies. As we continue to observe Betelgeuse and its behavior, it becomes clear that this star is more than just a fleeting spectacle in the night sky. Its unusual activity provides astronomers with rare opportunities to study the intricate processes that govern massive stars. Every shift in brightness, every surface mass ejection, and every sudden change in pulsation patterns brings us closer to understanding the mechanics of the stellar life cycle. One of the most fascinating aspects of Betelgeuse's evolution is that it is currently in a relatively uncommon stage of its life cycle as a red supergiant. Betelgeuse is nearing the end of its life, but its journey to becoming a supernova is not as straightforward as it might seem. The exact causes of the irregularities in its behavior are still up for discussion among scientists. While the surface mass ejection is one of the most dramatic events observed so far, it may mark the beginning of a more extensive series of changes that will eventually lead to the star's collapse. What's equally fascinating is that Betelgeuse's supernova could provide answers to some of the most fundamental questions in astronomy. The sudden demise of a star like Betelgeuse holds the potential to reveal insights into the nature of dark matter, the expansion of the universe, and the processes that lead to the formation of new stars and planets. These revelations could help scientists refine current models of the cosmos and gain a deeper understanding of how the universe has evolved over billions of years. The research being conducted on Betelgeuse is part of a broader global effort by astronomers to comprehend the life cycles of massive stars. Studying stars like Betelgeuse helps scientists learn about the end stages of stellar evolution, which are notoriously difficult to monitor in real time. The majority of stars die in ways that are incredibly distant and hard to witness. So when a star like Betelgeuse begins to show signs of its final explosion, it presents a rare opportunity to observe this cosmic process up close. One of the remaining unanswered questions is how long Betelgeuse has before it reaches the supernova stage. The timeline for the star's demise is still unclear, and scientists are constantly adjusting their predictions based on new data. Some astronomers believe Betelgeuse might explode sooner than expected, while others think it could take tens of thousands of years before the supernova occurs. Regardless of when it happens, the excitement surrounding the star's eventual explosion remains palpable. For now, researchers continue to monitor Betelgeuse closely, using sophisticated instruments to capture every possible data point. From ground-based observatories like the VLT to space telescopes like the JWST, scientists are utilizing the latest technology to take a deeper look at this massive star. The data they gather will help refine our understanding of stellar evolution and offer insights into the forces that drive the universe itself. As Betelgeuse's story unfolds, it serves as a powerful reminder of the magnitude and complexity of the cosmos. Stars throughout the universe undergo incredible transformations, but few offer such a clear window into their final years as Betelgeuse does. Its impending supernova will be a monumental event, one that could help scientists answer some of the most profound questions about the nature of stars, galaxies, and the universe as a whole. While we may not know exactly when Betelgeuse will explode, one thing is certain. Its death will mark a momentous occasion in the study of stellar evolution. Scientists worldwide consider it an event that will provide countless opportunities for exploration and improvement in our comprehension of the cosmos. And for the rest of us, it will serve as a reminder of the incredible beauty and mystery that surrounds our universe.